Greetings, Earth Science students. My name is Mr. Pawson, and I'm here to share some information about igneous rocks for you. Before we begin talking about igneous rocks, I just want to touch on the three major classifications of rocks. The major classification of rocks are really based on their mode of formation. So sedimentary rocks, these are rocks that are made from the weathered material of other rocks. Metamorphic rocks are formed when heat and pressure are applied to other rocks, other existing rocks, and that heat and pressure causes a physical and/or chemical change to that rock, giving us a metamorphic rock. Igneous rocks, on the other hand, are formed when molten material or liquid rock is cooled and then crystallizes to form a new solid rock. So the word igneous comes from the Latin meaning fire, and this is really appropriate because we need a lot of heat to melt previously existing rocks to give us this molten material that we can then form igneous rocks with. Over time, that molten material will cool and it will solidify or crystallize and form a new rock. If you remember from our mineral unit, minerals are the building blocks of rocks, and this molten material that eventually forms igneous rocks is really a mixture of all different melted minerals. So when we look at igneous rocks, we can actually classify them even further. And we do this using two methods. We can classify them based on their texture as well as their mineral content. The interesting thing here is that igneous rocks, the texture and the mineral content doesn't just tell us how we can classify the rock, but it can also provide clues to how and where these rocks are formed. So let's take a look at texture. So there are two textures for an igneous rock. We have intrusive and extrusive. When we look at intrusive rocks, these are rocks that, intrusive igneous rocks, are formed on the inside of the earth, and they're formed from what we call magma, which is just liquid rock that is beneath the earth's surface. Because they are beneath the Earth's surface, the Earth's crust acts as an insulator, allowing that magma to cool slowly. And as it cools slowly, that gives the minerals time to form very large crystals in the rock. On the other hand, we have extrusive igneous rocks, and these are formed at or near the Earth's surface. And we call molten material that is at or near the Earth's surface lava. Because they're at the Earth's surface, they cool very quickly because they don't have the insulating effect of the Earth's crust. And so because they're cooling very quickly, there isn't really time for crystals of those minerals to form very large at all. If we look at this granite, this is an intrusive igneous rock, and we can really see the mineral crystals within this rock, even with the naked eye. We have the pink feldspar, you can see the dark mica, as well as the white colored quartz. So just by looking at this rock, we can see those large crystals. We can say that this formed inside the earth from magma because of those large visible crystals. If we look at extrusive igneous rocks, we can see that there are no visible crystals in these. So if you look at basalt, for instance, it's very hard to see any distinguishing minerals within that rock. Same thing goes with obsidian and pumice. And even though pumice kind of looks like there might be some minerals, those are actually small holes, or what we call vesicles. And that forms when there's gas trapped inside the lava. I kind of like to think about it like blowing bubbles into your chocolate milk, and then that chocolate milk solidifying, leaving behind those trapped gas pockets. So there are four ways to describe igneous texture. The first way is coarse-grained, and coarse-grained are any igneous rocks where we can see large visible minerals intergrown together. So if we look at this piece of granite, we can see those the feldspar, the mica, and those quartz crystals very clearly with the naked eye. So we would call this a coarse-grained igneous rock. This here, basalt, again, it is fine-grained. Fine-grained are any igneous rocks that have really small crystals that we can't really see with the naked eye. We might need a microscope to see those crystals. Glassy is another way to describe the texture of igneous rocks, and these are no crystals have formed. So these rocks have cooled very quickly, and crystals did not have an opportunity to form in any kind of shape. Obsidian here has a glassy texture, but then pumice, which has all of these vesicles or holes that I mentioned before, we would also consider this as having a glassy texture, because when we look at it, we can see no crystals in there. And then finally, we have porphyritic. And this is when an igneous rock has both large and small crystals. And if we look at this rhyolite here, we can see that there are some large light-colored mineral crystals in it, but then there's also a lot of small gray-colored minerals in there that we can't really see with the naked eye. So we would call this porphyritic. And this really just indicates that this rock has had periods of both really slow cooling beneath the surface, but then also some quick cooling near the surface. So we've just discussed texture. We can determine texture based on the crystal size, whether or not it has air holes or if it's glassy. This also determines whether or not it's intrusive or extrusive. Remember that intrusive igneous rocks, they're going to have large crystals, they're going to be coarse grained, whereas the extrusive, or those forming on the exterior of the Earth's crust, are going to have really small or no crystals. We can also describe igneous rocks based on their mineral content. And geologists use the color of the rock to infer mineral content. Dark colored igneous rocks are going to be made up of magnesium and iron. They're going to have very little quartz in them, quartz being a silicate. Igneous rocks with a lot of silicate are going to be lighter colored. So looking at this, we can see that it's a dark colored rock. It has very little silicate in it, but it has a lot of magnesium and iron. And these igneous rocks tend to be more dense than their lighter colored counterparts. Mafic igneous rocks make up oceanic crust. It is very dense. Anytime we have a dark igneous rock, we're going to refer to it as mafic. On the other hand, we also have light-colored igneous rocks, and we would refer to these as felsic. They contain a lot of aluminum as well as silicate or quartz. These tend to be less dense than mafic igneous rocks, and they make up the majority of continental crust. I do want to point out that we have a kind of a continuum of these colors for igneous rocks. So on the left-hand side of your screen, you'll see very dark colored igneous rock. We would refer to this as ultramafic. It has very little silica content compared to the other rocks, but it has a lot of magnesium and iron in it. The next dark colored rock would be considered mafic, and again, we can infer that it has less silicate minerals than the intermediate or the felsic, but it has more silicate than the ultramafic igneous rock. And then as we move down, intermediate would be between mafic and felsic, and then felsic being that light colored mineral. It has very little magnesium or iron in it, and it has a lot of silicate mineral in it. So again, I just wanted to touch upon the two different types of crust that we find on Earth and what they're composed of. Continental crust is really made up of felsic igneous rock, and this really gives the continents very low density, and they tend to float really high in the mantle, whereas oceanic crust is super dense. It is typically made of mafic igneous rock, and that kind of sinks it down into the mantle of the Earth. So when we are classifying igneous rocks, I want to just point out that not only does this tell us where and how the rock was formed, but we can also intermingle both texture as well as composition of the rock. So for instance, basalt, it is an extrusive rock, so it is fine grained, but is also mafic because it has more magnesium and iron in it and less silicates. It's a darker rock, so we would refer to this as an extrusive mafic igneous rock. On the other hand, if we look at rhyolite, rhyolite is also an extrusive igneous rock, but it's also light colored, so we would refer to it as felsic. If we look at gabbro and granite, we can see that both of those are intrusive igneous rocks. They formed inside the earth. We know that because they have this coarse texture to them. We can see the mineral crystals in the rock fairly easily. But one of them is mafic, meaning that it's composed of different types of minerals, specifically magnesium and iron, and it has very little silicate minerals in it. Whereas granite, also an intrusive igneous rock, is felsic. It's light colored, and we can infer that it has a lot of silicate minerals in it based on its color.